Hello, everyone. Welcome to the December AMER EMEA edition of the Ops Engineering Demos. Today is December 1st or December 2nd, depending on where you're watching this demo from. Today we have a demo from Eduardo from the Incubation Engineering Department. He will be talking about pipelines for hyperparameter optimization. And so, Eduardo, if you're ready, the stage is yours.
Hello, everyone. How's it going? My name is Eduardo. I am the incubation engineer for MLOps, and my goal is to make GitLab a tool data scientists love to use. And there are many ways data scientists use GitLab. Most of them because they have to, not because they want to, and that's because it's not thought out for them. So I'm exploring a little bit some different use cases for data science within GitLab, and one of them is pipelines. Now, for data science, pipelines works a bit different because they're strongly tied to the creation process. When you create a machine learning model, you often don't have the compute power on your machine to run the training necessary, or it takes too long, or you have to run too many times. So you can think as pipelines as editing the code in itself. This is how data scientists need and machine learning engineers need this, also for data processing. So pipelines are used across the entire life cycle of data science and machine learning development. And to explore a bit how to, if and how GitLab can be used for this, I am working on hyperparameter. I'm going to share my screen. I'm working on hyperparameter optimization. And I know it sounds a little bit crazy, but hyperparameter optimization is when you create a machine learning model, you have an algorithm that you use for this machine learning model. And this machine learning model, this algorithm has parameters, has configuration parameters. So you have parameters for the data itself, for the training, but you also have parameters for the model. So for example, if I go into sklearn random forest over here, random forest classifier, on the constructor of the model, I have a lot of different configurations that I can set. And this can make a big difference on the model results in the end. So they can, you can get wild variations on the results depending on the hyperparameters that you set. And hyperparameter optimization is one way, is a way to automate searching for the best hyperparameter for your use case, right? And the thing about hyperparameter optimization is that it's a search problem. And a search problem where searching for each of the specific trials can take hours, can take days, can take weeks. So it's really important to put this in a pipeline that runs somewhere on the cloud that you don't need to run on your local machine. And it is also the first step if we ever want to move towards AutoML. So creating, you give the data set, you create the, you set the metric, and then with the machine figures out by themselves the algorithms and everything. This is AutoML. This is the first step towards AutoML. So this is why we are working on this. This is a series of, I don't know, steps that we are working on. So right now I've done three steps actually. So the 0 is a video explaining hyperparameter optimization. So if you want to know a little bit more, I go a little bit more into details of what I just described. And then the first part is the simplest hyperparameter optimization pipeline. So I can go over here. This is, I have I'm going to add the links later. And this is I have a repository with all of them. Each part is a branch and has a merge request. So the simplest one, what it does is that it generates synthetic data, just so it becomes as quick as possible for me to try it out. Then it reads the hyperparameters from a YAML file and then runs a very simple hyperparameter optimization, which is brute force. It's basically brute force. I have a few options, and then I try them all, and then I choose the best. It is very dumb, but it works. And it's good for this trial. And then it uploads the results as into the AMER. So for example, I have the pipeline that ran over here. Let me open up the pipeline. Where is it? Oh, here. Where's the pipelines? So very simple. It's just one job. And what it does then, it adds the results into the overview. Then you have here the test score for each one of the trials. So you can see that it moved from the worst at 0.73 to 0.75 almost. It doesn't seem much, but when you're running a multi-million-dollar revenue, if you can increase your revenue by 1.5% just by doing this, that is a huge thing, right? This is free money you're getting almost. So it is very simple. So if I go into the pipelines for this one, like the editor for that one, so this one, yeah, very simple. Just a few scripts that I'm calling. I generate a fake data set. I have a very simple script that does the optimization. I format the results into a pretty markdown, and then I publish this AMER to the, I published a message to the AMER with the results. Now, this is very simple, it works, but on this specific case, it takes about, I don't know, 1 second to train each model. I have 18 combinations of parameters, and because it uses cross-validation, which is a different way of testing, no, not a different, but a common way of testing machine learning models, it trains 90 models. So with very simple hyperparameters, these are the only hyperparameters that I have are these ones. So if I open this one and then over here over here, these are all the hyperparameters that I'm testing. So 3 different hyperparameters, 3 values for 2 of them too. So it's already 18 results. And then I multiply by 5 times that I run each model so I can test them properly. There's already 90 training. So, and it takes 1 second, it's okay. But imagine that on the real world, training a machine learning model can take hours, days, sometimes weeks. There are machine learning models that take weeks to finish. Running this in sequentially, it becomes impossible. So we need to find a way to run them in parallel. That's what part 2 is all about. Part 2 tries to make this on a parallel way. Problem being that we face then is that there are no dynamic ways of building the pipeline. Well, there is. I will get into it very soon. So I don't know at coding time how many hyperparameters I will have. This will come from the hyperparameters.yaml file or from an external file source that I'm defining somewhere else. So it needs to be able to build this at runtime, at the time the pipeline runs. This is why I use a dynamic parent-child pipelines. So this one, it's a lot more complex, but not so much. So if I go into the part 2, it seems a lot simpler. So it has just 2 steps. The first one, it generates a CI, the optimization CI, and the second one triggers the CI, right? And if I go over here, then on the pipeline, and then if I come on this one, very simple for now, but if I click over here, then it shows the true colors. So you have one step to fetch the data and then generate the trials, the configurations, and then each one of this will run a specific trial. And then they save. So if I check the artifact, can I check the artifacts of this one? Pop up. Let me see if I can check the artifacts. Okay, yeah. So if I go into over here, each one of them is going to generate a CSV file with their results. And then on, which looks like, let me see here. And then on the fetch job over here on the format results, it will read all of them, concatenate, run statistics on top of it. So compute the mean, the best and everything, generate a message for the next one to publish. So if I go here into my VS Code, this is what the child pipeline looks like. This is the template. So you have the fetch data, generate trials, and then you have a template for the run trial. This is Jinja 2. So now I have a for loop that will pick up all of the trials that need to be run and create one run for each file. So the resulting is something like this. So all the trials, all this, so there are 18 use cases, 18 trials being run, and then format results, and then there's this huge this huge needs over here, because the format results need the results of all the previous trials. And yeah, so this is the result. This is the part 2 already, and where we're at. Some limitations over here. It's not fault tolerant. So sometimes, like if we're running 100 trials, if one of them fails, tough luck. Like you just call it, you take the loss and you move on. Over here, that's not really the case. So I need to get all of them to run, otherwise the publish, like the format will not be working. I'm sure there's some way I can configure this properly, and I will look this eventually. Another issue that I found is that for me, the iteration time of change, upload, wait for pipeline to finish, change again, it's really slow. And using the dynamic pipelines, it becomes a lot slower because you cannot rely on the online editor. And if you cannot use the online editor, since it's dynamic generated, you have to keep trying and pushing and trying and pushing and trying and pushing. So it becomes really a lengthy process. But that's not what we, okay. What was the other limitation? Oh yeah. And then other limitations that sometimes the pipeline fails on the last step. And then if you want to change, you want to update, you have to wait for all of them again. You have to run everything again so that you can test like the pipeline on the last step. It would be cool to have the concept of checkpoints. So you run the pipelines and they run fine until like step 5, and then step 6 fails. You can retry from step 6 onwards by keeping the configurations up until step 5 or the last pipeline that was run. That would make process a lot faster, and it would make resource consumption a lot lower during this process, because you can reuse the whole thing that was done before, right? So the concept of checkpoint would be really cool to see at some point. What we are doing next on this project is I'm still using brute force, and that is not the smartest way to look this. It is a search problem, and brute force is not a good solution for this. I want to move to A star, or similar to an A star solution, which is an iterative solution. Like you run some trials or a genetic algorithm solution. So you run some trials, get the results, create more trials, run more trials, get the results, create more trials, and to converge into a final solution in the end. That means parallel is not enough anymore. I have to code a for loop into the dynamic pipeline, right? And I'm very excited about this step, because this is definitely not what this was done for, but this will happen. And in the next one, we're going to do that. Also converting Jupyter notebooks into GitLab pipelines automatically. So you publish a Jupyter notebook, and then you can use dynamic parent-child pipelines to create your pipelines directly from a Jupyter notebook without having to transform into Python notebooks. And also, also connecting to model registries. So upload this artifact somewhere else, and so on and so forth. So if you want to check out and, I don't know, get updates on this, I have an epic, which I will share on the docs later. I try to post a small video after I finish every step, that I go a little bit into more details of what I did on that specific step, along with the slides and some document and some docs. So if you're curious and you wanna get more details, I spoke about, for example, cross-validation. I didn't explain what is cross-validation, why is that important, or how does it impact this whole endeavor, but it actually causes somewhat of an impact. And you can look better over here. So be putting more stuff on, I think, the next video about this last step. I just finished the pipeline today, so I haven't finished the video. I'm going to post the video tomorrow, and then keep going on the next steps. And yeah, so I know that I have a screw and I'm trying to use a hammer right now, but it's fun.
Eduardo, first off, thank you for doing this demo. I mean, I think it's really exciting and cool. I know we have a couple of questions. I guess I'll start with the chat. Mattia or Miguel, do you want to verbalize any of your comments that you put in there?
Yeah, it's just a quick remark. Instead of defining like 10 essentially the same jobs that you want to run in parallel, you would just use the parallel keyword, which is basically, I think, what you need. It also exposes the index and the total. I know you used like a manual variable for the index, so there's an automated way to do that.
Yeah, that will solve the problem for this one. That won't solve the problem for the next step, which is the iterative approach, where I have to create a for loop. For that, there is no, so each loop can be a parallel, but I have to aggregate each parallel into its own collect part of the loop. Think of MapReduce. What I'm going to do is going to implement a MapReduce within GitLab pipelines. That's basically what's going to happen. So each map can be parallel, but they need to end up in a reduce step. So yeah, but for this one, that would work. That would work really well. I'm going to add this. I'm going to save this somewhere. I'm going to stop sharing my screen. Otherwise, I end up sharing. I don't know. You don't need to see everything. Okay. Yeah.
Great.
Yeah,
Miguel, did you want to elaborate on your comment?
Yeah, I also added a note that needs may not be the right tool for this job. If you want to wait for every job in the previous stage to finish, maybe simply using stages could be easier for you. I think you said that you had to wait for that you were not able to fail a job, so maybe allow failure could help. But there's just things that may not help you in the next stage anyway.
I think the allow fail helps. The needs as well, because there's this entire job that is running, and then the next steps that would help a lot. Yeah, those allow failure would help a lot on this. It doesn't really
Okay,
matter if you lose 1 out of 100, right?
I know we have a few questions, it looks like, in the agenda too. One of the questions I had, Eduardo, is when you were going through this process, you talked about some of the challenges with maybe the dynamic pipelines being a little slower, but aside from that, were there other challenges you may have encountered? And I guess, were there other things that you're considering in the future for enhancing or improving upon? You talked a little bit about the brute force approach. I guess, what does the future look like as far as next iterations of this?
So the first point that we need to consider is that the users are often not software developers. They don't have that that familiarity with building pipelines and with YAML files and with GitLab itself. For them, it's they need the simplest way of putting this online. This is why the fifth step is to converting Jupyter notebooks into pipelines directly. Second, I did find documentation a bit scattered. For example, this only runs for merge requests. And then I added only merge request on all steps, and for some reason it wasn't working. And then somewhere else, I found out that you actually have to use the rules if CI merge ID or something like that. But it was not really straightforward of that. That kind of like the documentation is generally really good, especially if you compare to the other tools that we have that data scientists actually use for this. For example, Kubeflow. We use Kubeflow pipelines are used for this. This is a lot better, but yeah. And another thing is that the fact that it's tied in to a commit or to the pipeline, or it's tied into the repository in itself. So often when, for example, when I used to run on Kubeflow pipelines or something like that, it was completely detached, like the CI, the Git from this pipeline running. I don't know whether this is a bug or a feature. It might be that enforcing this thing to be tied to your CI or running might be a good thing on the long term. But like I said, this is part of the create process of data science and machine learning. So it is not only after you code that this becomes important. It is generating the hyperparameters. You can think as generating the coding itself. It's part of the entity, of the code entity that you have, right? So it starts a lot earlier on the development process. To have your dependence on pipelines start a lot earlier on your development process from the get-go. When you start creating a new model, you're already looking at pipelines. It's not like when you're creating an application that you've created an application and then, okay, I need to deploy, and then you start thinking about pipelines. No, it happens a lot before. So the persona here is different that we're looking at, with different goals, different use cases. For example, I want to try out TensorFlow, and TensorFlow can be very heavy on the GPU side and on the CPU side. Can we handle those use cases in the end? It's common to have, like, when you're using TensorFlow, you need you have a debugging UI called TensorBoard. Can we make the TensorBoard available from the GitLab CI pipeline? In the end, I think it's a really, like, GitLab has a really good shot over here because it's already there, and setting up a pipeline tooling is not straightforward, especially Kubeflow pipelines, which run on top of Kubernetes. Not everyone has that, or you have to use Airflow, something like that. But if you have this on GitLab, it just makes it so much easier. But yeah, so this is what I'm doing. I'm trying to figure out how much does it take to transform the hammer into a drill.
Great. Fabio, would you like to verbalize the next few questions you have?
Yeah, I'm gonna skip one because it was already asked by Matthias, pretty much the same thing. I have another question. So what are the events or triggers where we need to run like a ML training pipeline? Is it like on a scheduled basis, or when some changes happen to the training set? And what would normally be like the event that would trigger like a new training pipeline?
They can happen over scheduled periods of time. They can happen when there is a considered change on the underlying data set, something that we call concept drift, because a machine learning model is really coupled to the data set that was used. We say that for each version of a machine learning model, you need to version 3 things: data set, hyperparameters, and the code in itself. So these are the entities that become a machine learning model. Whenever the underlying data set change, like when there's a population change, for example, like COVID hit or something, your machine learning model will not do a good job anymore. So when the underlying data set changes, you have to retrain the model. It can be when the code changes. So this is where it's tied more with the CI. It can be during creation process. So I'm just trying out a new model and it's not really tied in. I don't want to push this code to Git yet. I'm just testing out this model, right? Just trying the things. So this is a step where this happens. So yeah, so from the top of my mind, so coming from the fact that there are these 3 entities that make the machine learning model, whenever each one of them changes or can change, that is important already to run the pipelines again, and during the development, and often also on a daily schedule. Usually the daily schedule is done a bit to avoid the changes on the underlying data. So you run daily because, okay, new customers came in, so I need predictions for those customers as well. I don't know. It also depends a lot on how the machine learning model is implemented. If the predictions are batch predictions, so you save before the predictions, you have to train very often. But if you train offline and you make predictions online with new data coming in, then it's not that necessary to do the pipelines, to run the pipelines all the time.
Yeah, makes sense. So it will be more like if I'm making changes to the model, not the data set, then that will need to run as part of a merge request pipeline, for example. Is it? And
yeah.
And if then like I don't make any changes, it's only data set, like new data into the data set that has been added constantly, then the overnight pipeline schedule should be enough to cover.
Could be, should be. It will depend a lot on the use case. It varies from, but these are the cases where things can happen. It's not exactly that, like each model, each application will have its own set of requirements, right?
Okay. And my other question is like, you mentioned earlier that there might be scenarios where a specific training job fails. So you just want to go and retry that specific job, right? So what will be like the scenarios where a job might fail?
It's easier, sometimes it's easier to come up with scenarios that it will go correctly than scenarios where it doesn't, where it fail. No, but it's, for example, so it relies a lot on GPUs can fail, or the libraries can go, like the data in itself. Like I said, it depends a lot on the data, and depending on the splits of the data that end up on each specific trial, you can lead to, for example, scenarios where the machine learning model, the training doesn't converge. So it would be forever on a specific state, and you have to kill that for some reason, or it ends up dividing by 0 somewhere because of truncating the booleans at some point, or the other way around, it explodes to the other side because you're dividing by a very small. So it's a very numerical process. You can expect every numerical issue to happen at some point. plus all the regular problems that you can see. So it might be that a lot of times it's not deterministic, so it can fail for 99% of the cases, but you forgot to take into account one variable that becomes null on a new data set that is coming in.
Okay.
And now it breaks the code for some reason. And yeah.
So it sounds like it might be helpful, or you probably are using already, like the automatic retry feature of the job.
Not
where
yet.
You can set like a number of times you want the job to be retried automatically.
Yeah. And one thing that it's important to keep in mind is that I am the user in this case. I haven't coded a lot of the GitLab CIs before. And YAML in general and Kubernetes, everything that uses like this configuration is a bit of a spell book. Like you need to know the magic for you to before so that you can use the magic, right? You need to know the incantation, the right type, the right words to type for it to do the thing you want. So I'm battling this process, and this is good because then I get the feeling of what a data scientist that is coming in and wants to use GitLab CI would face, right? And I'm trying to write down as much as I can, but yeah, we'll probably have eventually be writing a how-to specifically for data science with the corner cases and things like that.
That's good. Thanks, Eduardo. It's really interesting.
All right, I think unless there's any more questions, again, Eduardo, thank you for demoing. Thank you for everyone attending. In the meantime, have a great what's left of your days, or if you're starting them, have a great day, and look forward to seeing all of you again very soon. Thank you.